In this section, we'll look at some of the processing of minerals and the way it's done with a couple different metals. It has some similarities, some are completely different. One of the chief types of processing minerals is called smelting, and this was a very important part of the history of Pittsburgh with our steel industry and iron industry in the area. Basically, to make steel and to get iron from iron ore, you take iron ore, mix it with limestone and coke, which is coal that's been cooked at a high temperature. That coke is some of the things that help contribute to the high pollution in Allegheny County, both down along the Mon River and also from the coke works that's on Neville Island that comes near my home. Another similar process is done for other minerals like tin, lead, copper, etc. And then it's a different process known as electrolysis for aluminum. This is a picture of a typical blast furnace that's used for iron. And you can see over here that going into the blast furnace are the iron ore. Sometimes they use other pieces of scrap iron as well. Most of the time they do. You add limestone, and that's in the form of a slurry, and that helps just remove impurities from all of this. And then the coke, which is the hot coal, and that all gets put into a big hopper and put into the blast furnace. Usually there's hot air that needs to be injected into here. The technology's improved quite a bit in the last 40 years or so, where they can get a higher yield with changing the amount of air that's put in there. This is heated in this furnace for quite some time, and then the molten iron is pulled off the bottom of this. It's the most dense of the materials that are in the blast furnace, so it's going to be at the bottom. And I think really this slag thing should be a little bit higher. The slag is, I said, it's a mixture of the limestone and the impurities, and it's usually siphoned off the top part of the molten material that's within the blast furnace, and it's usually just kind of a waste material, but it can be used for like gravel for driveways and some things like that. This is a picture of processing minerals such as you can look closely in here and see it mentions zinc and lead. A lot of times zinc and lead kind of go together when the minerals form. So a similar type blast furnace, you have some air that's blown in there. The tire is actually just a place where it ventilates the hot air through here. The hopper dumps the materials into the blast furnace. They're heated. Here it's showing that it's separated, and the cooled lead and zinc, and the molten lead forms one way and the zinc goes another way, again based on density differences between the two metals. Aluminum uses a much different process. As I mentioned, how aluminum process changed once this electrolysis process became invented in the early 1900s. Here we take bauxite ore, and it's purified first into aluminum oxide, and you mix it with this material known as cryolite. It's melted all together about 1,000 degrees, put in a big vat, and then you have two electrodes, an iron cathode and a carbon anode. And this then has the at the cathode, the aluminum turns into, the aluminum ion becomes pure aluminum, and then it's separated and the molten aluminum comes off from the mixture. You really don't need to know these exact processes for AP Environmental, but I just thought kind of as a historical perspective, and to realize that kind of think about the energy that's involved, if anything, from these. Electrolysis is a very high cost of electricity because it is an electrolysis process, so there has to be an electric current flowing through here. The other types of processes, the smelting and in the blast furnace, high temperatures for heat, so you're going to have to provide some sort of fuel to get that fire started, whether that's natural gas or coal or some other form of energy to get that started. Also think of the costs of transporting materials, etc., to these places where they are processed. We'll talk about the effects, the environmental effects, in a bit. So when we think about all these minerals, we have to think about what's the effect on our environment, and there can be in a number of different ways. One could be just the very basic process of how we're extracting them from the earth. When we remove them, we are removing all the vegetation. We're removing the overburden and putting in these spoil piles. These spoil piles, these spoil banks, they're susceptible to chemical weathering, erosion, wind. There's no topsoil on these spoil piles, so you usually don't get any vegetation to grow on them. So there's a lot of places where this the scarring can happen on the land surface because of just the initial process of removing the topsoil, the trees, and getting to the mineral even in the first place. A second harmful effect that we've talked about is the mountaintop removal. Removal mining, it covers the streams, fills in the valleys. That's going to lead to an increase in flooding hazards. Up near the top you get sludge ponds that form that release these toxic substances, dust from the blasting. All of these are effects of the mountaintop mining. Another problem is with open pit mining. They tend to use a large amount of water. If you think about what an open pit is, digging a hole deep down into the earth, making a large pit. As you go into those lower levels of the earth, just even 100, 200, 300, 400 to 1,000 feet down, you're going to run into some water that's in different water tables. You have to pump that out. Typically, it's just considered wastewater. That's going to cause that to dry up. And so you're going to have less water because you're essentially pulling water out of an aquifer. It might not be the biggest aquifer, but you're pulling water out of that. Open pit mining is probably one of the biggest types of mining in the western states, and those are those states that also have the least amount of water, so this is especially important for them, that here they are needing water and it's being wasted because of their method of open pit mining. Another problem we see in this area a lot is acid mine drainage. This is when sulfide, which would be the sulfur ion in minerals, combines with water and it makes sulfuric acid. When this occurs, the sulfuric acid is then able to act on heavy metals that might be in the area, and it allows them to become dissolved, and then they are being able to be transported down the stream. So iron, which would not be normally considered a soluble mineral, when it combines with the sulfuric acid, it does become fluid, essentially. It becomes a solution. And so you see these streams in the area that are these orange colored streams. You can see this right down at in Bridgeville at Chartiers Creek. There actually is an acid mine remediation spot right over next to Boys Mayview Park, over towards Ardolino's Pizza. And you can walk down through there and see that the water coming into that remediation area is an orange color. They've put a remediation in there and it's clean when it leaves that area. Some of the other things to think about in terms of harmful effects, that it does require a large amount of energy to mine and refine. For gold, for example, you have to dig minimum of 2,000 pounds of rock for just 0.7 grams of gold. So you're going to have to remove a lot of rock. What's that going to cost you in trucks and bulldozers and blasting materials and everything else, labor, to extract that small amount of gold? Typically, when we also have mining, it's going to end up decreasing the biodiversity. This can be caused from just the removal of all the plants. Even if you do go back and remediate, you're probably not going to put in all the plants that are there. We also can see this in tropical forests. You can see this in small scales. They often use what are called water cannons to wash away the exposed hillsides, and that's just going to expose this material, expose the minerals they're after, but then it also washes away all of the normal material in the area. Underground mining, there's actually a little bit less waste, I guess, because everything has to be done in the ground. There's less waste, but there are certainly some other hazards to be concerned about. Cave-ins, explosions, fires, black lung disease. Mine subsidence, another issue. Mine subsidence is when land that's above a mine, whether it's in a currently used mine or an abandoned mine, would collapse. You can actually go to the Department of Environmental Protection for Pennsylvania and pull up a map of Upper St. Clair Township and look to see if your home is actually under or on top of an abandoned mine. I would strongly suggest that you do this, or have your parents do this, is just go to this site and see if you can see where your house is located and see if there's an abandoned mine or a currently operating mine actually under your property. If that's the case, you may want to consider getting what's called mine subsidence insurance, and that would take care of any mine subsidence, because if the ground falls in, there might be a chance that your house could too, and or at least crack, do some things like that. So that is an issue.